Back. In this video, we're going to practice implicit differentiation for a function given implicitly here. And the ultimate goal is going to be to find a tangent line to the graph of this implicit function at point 3 and 0. To achieve this goal, we need y prime, which is dy over dx, the derivative of y with respect to x. That evaluated at 3 is going to provide us the slope of the tangent line. So once we have the slope, since we're given the point as well, so we can use the point slope form of the tangent line. All right, let's move on. Following the guidelines of implicit differentiation, we're going to take the derivative of the left-hand side and the right-hand side. So let me just write it down here. Okay. So we have an exponential term raised to the power of x and y, and we know how to take care of the exponential function's derivatives. Okay, so it's going to be 3 times the derivative of the exponent times the exponential function itself, so e to the x, y. Okay, and the derivative of x is going to be just 1. So the question here is how we take care of the derivative of x times y, because it's the product of x and y. So we're going to essentially use the product rule here. This derivative is going to be the derivative of x, which is 1, times y, plus the first one here times the derivative of y. And that is exactly equal to y prime. Okay? So this takes care of the derivative of xy prime. We still have e to the xy, and we still have minus 1 equals 0 here. Well, to solve this equation for y prime, why don't we just add 1 to both sides of the equation? All right, on the left-hand side, we have 3 and e to the xy multiplying parentheses term. So why don't we divide both sides by 3 times e to the xy? It turns out that y plus xy prime is 1 over 3 times e to the xy. And then subtracting y from both sides takes you all the way to xy prime equals 1 over 3 e to the xy minus y. And eventually we're going to divide both sides by x to find y prime. So all we're going to do is to evaluate this expression for x equals 3 and y equals 0. So since x and y are 3 and 0 respectively, so e to the xy is going to be e to the 0, which is equal to 1. Y is already 0, and x equals 3. It turns out that 1 over 3 over 3 is the answer. But we know that 1 over 3 over 3 is going to be 1 over 9. So the slope of the tangent line is 1 over 9, and we have the point provided to us. And in the next step, we're going to write down the equation of the tangent line with slope 1 over 9 and the point that it passes through 3 and 0. All right, so we have the slope 1 over 9, and the point is 3, 0. And the slope point form of the line is y minus the y entry of the point equals 1 over 9 x minus, which is, this is slope, times x minus the x entry of the point, that is 3. So it turns out that the slope point form of the line is 1 over 9 x minus 3. And this is the graphical outlook of both the function in the implicit form and its tangent line that we just came up with. The tangent line is a red line, and then the blue curve is the implicit function. As you see that at point 3 and 0, we have a perfect tangent line to the curve. All right, that ends the video. Thanks for watching. I'll see you in another video. Bye.